Video 2.11 is all about ternary compounds. So now we're going to have compounds with three or more elements instead of just the two elements that we've had in the past. So we're going to talk about how to name these. And hopefully by the end of this video, you'll be able to write the names and the formulas of these compounds with three or more elements in them using the stock system, they call it. So ternary compounds have, like I said, more than three elements, which means they usually have a cation and then a polyatomic anion. Polyatomic is many atoms, but it's still an ion, so it has a charge. So polyatomic ions act as one ion, but it's usually two or more elements bonded together. So you see here the anion for this compound, NO3, is nitrogen and oxygen, both negative. They act together as a group. So we name them together. And the way that we do that is in your reference table, there's a chart. It is table E. It will be very important to you because it has all the names and formulas of all of these polyatomic ions. So it will be your best friend for naming these types of compounds. I also, to go back to video 2.9, looked at your periodic table and it does have the charges on it. So you're good to go with that too. But for now, table E is your best friend. So you see here we have AgNO3. Silver is AgNO3. When you look at the chart, is nitrate. So you just write that down. That's how you name it. The cation, the name of the element, the polyatomic ion, straight off the piece of paper. You don't make any changes. So here's a couple more of these. CaCO3 is calcium carbonate. Again, that CO3 just came straight off the chart. Pull it out if you want to. Pause the video so you can kind of follow along. Lithium chlorite, ClO2, chlorite, right from the chart. Sodium hydroxide, ammonium phosphate. This one's a little bit different. You see how there's four elements. The ammonium, it is also a polyatomic ion. It came from the chart. And then the phosphate also came from the chart. So for this one, both of these polyatomic ions are right in table E. You can look them up, and that's how you write down the names. Ooh, I went backwards a little bit. So here's some more examples. Pause the video, pull out table E, and see about doing these. You don't need to write them down. Just make sure you can name them. Here's the answers. We have potassium sulfate, cesium nitrite, barium thiocyanate, strontium chlorate, aluminum hydrogen carbonate. This one we got the aluminum, but when we look this up on the chart, HCO3, it is hydrogen carbonate. And then rubidium cyanide. Again, the CN is straight off the chart there. Now, when we go the other direction and write the formulas, same rules as before. The charges have to balance to zero. We can do the whole crisscross, except this time we deal with the polyatomic ion as one thing. So we don't look separately at the carbon and the oxygen for this example. We look at the chart, table E, and it will give us the charge. So this one I have calcium with a +2 charge, and this one with a -2 charge. So they react together, and we get CaCO3. It doesn't get any extra numbers, but the 3 has to stay with the oxygen. So we got our calcium carbonate. And then this is lithium and sulfate. We've got a +1 charge here, a -2 charge here. So the lithium needs a 2. Let me cross those numbers. But the sulfate, the SO4, just stays as it is. Now we have magnesium as a +2 and NO3 as a minus, which means I have 1 magnesium and 2 nitrates. That's what this crazy thing is supposed to be. But let's look down here at this. Ignore this right here. Ignore. 2 magnesiums, 2. That's why we have the parentheses in that little 2. It means I have 2 nitrates. 2 magnesiums, or 1 magnesium with the +2 charge. 2 nitrates with the +1 charge. Let me erase this. We'll try some other examples here. So, maybe pause the video and look at your chart. Write down the formulas for these. For the first one, we have potassium and chlorate. +1, -1 means I just write down KClO3. Sodium carbonate, you see a +1 and a -2. So to balance those out, I need 2 sodiums, Na2CO3. Magnesium has a +2 charge, acetate a -1. So I'm going to need 2 acetate groups. That's when it gets put in parentheses and I put the 2 outside. So that means there's 2 acetate groups in this molecule. And then strontium phosphate, a 2 and a 3. So this is one of those where it's easiest to crisscross. 2 phosphate groups and 3 strontiums balance out those charges. So strontium phosphate is SR3PO4 2. Excuse me. So now you should be able to write the names and the formulas of these compounds with polyatomic ions. Remember, table E is your best friend for these. Make sure you always have it handy and ready.